Now let's see the concept of demand paging. Okay, so virtual memory is implemented by using the concept of demand paging. Okay, what is mean by demand paging? Demand paging says that the pages are loaded into main memory only when they are demanded during the program execution, until and unless it is referenced by CPU. It is referenced by CPU, the page will not be loaded. Okay, the pages that are not accessed, that will never be loaded into main memory or physical memory. Okay, so whenever the program is running, the pages are accessed or referred, those pages will be loaded into main memory. Okay, so it will use the concept of lazy swapper or lazy pager. Okay, so what actually will be done, let's see this particular process. So this is our disk, this is our disk, this is physical memory, and this is our page table, and this is our logical memory, that is our process. And the process has been divided into how many pages? 8 pages, A to H. Okay, and there is a page table, there is a page table, each page number, okay, each page number is a index to this particular page table. And now write down the page numbers and this particular thing. So how many pages are there? 8 pages, where they are actually stored in the hard disk. But is all the pages are loaded in the main memory? No. How many pages are loaded in the memory? A, C, F. A, C, F, and remaining this particular B, D, E, G, H are not currently loaded in the main memory. So what will happen here? That means the CPU actually loads only three. These three are accessed. These three are referenced. Okay. Now, how to identify which process will be present in the main memory and which process is not present in the main memory? Okay. So there is a bit called valid invalid bit. There is a bit called valid and invalid bit. This particular valid invalid bit, okay, this particular valid invalid bit will says that which process is currently, which page is currently loaded in the main memory and which page is not loaded in the main memory. That is, look at here, A is loaded in main memory and C and also F is present in memory. These three pages, that means page number 0, page number C, that is 2, and page number F, that is 5. So 0, 6, 9, they are loaded in main memory. Okay, sorry, 0, 2, 5, they are loaded in main memory, where they are actually loaded on the frames, frame number 4, frame number 6, frame number 9, on the frame number 4, 6, 9. So this is frame number 4, where page 0, that is A, is loaded, and page C is loaded into frame number 6, F is loaded into frame number 9. Okay, so now if this particular I, what is this particular I? These particular pages are not loaded in main memory, are not loaded in main memory. So valid and invalid bit, it is says that a page is loaded in, present in main memory or not. Valid means the page is present in the main memory. Invalid means the page is not present in the main memory. So for that, we also add one more column to page table, that is valid, invalid. Okay, so from now onwards there is columns that will be added to page table. Okay, so what is demand paging? Whenever a page that is referenced, then only that particular page will be loaded into main memory. Initially few pages that will be loaded into main memory. Okay, after that, if a page is present in the main memory, it will directly take that directly generate the physical address and the execution will be proceeded. If it is not present in the main memory, then this particular invalid bit says that the page is not present in the main memory, so you need to take this particular page into main memory. Okay, take this particular page into main memory. There are two cases. Let's see case 1. What is case 1? Okay, let's see the scenario. Look at, we have 8 pages and there is a table. Okay, the table consisting of page numbers that are indexed followed by frame numbers and valid and invalid bit. So CPU wants to access the memory of a particular page, and that page, okay, it will check with the page table, and it says that the page is not available in the main memory by looking at invalid bit by looking at invalid bit. So when you try to access a page that is said invalid, that says invalid, then the system rises, okay, page fault error. Okay, so what is mean by page fault? The page, it says that the page is not present in the main memory. The page is not present in the main memory, so the operating system first loads that page into main memory. Okay, the paging hardware, because we don't the main memory. Okay, now what are the steps that should follow to load into main memory? First, look at here, system says that load m. System says that load m, that means it has to load some particular page. Okay, then first it will check, step number one, it will check in the page table. Page table says it is invalid, that is not present in the main memory. So what will happen, this second, in the second step, the system will raise an error that is called trap to operating system. The program will raise a trap to operating system. Now it is the responsibility of the operating system that the page is present in your hard disk, that is your backing store. The page is present in your hard disk backing store, then this particular page will be loaded into main memory. Before loading, the operating system checks if there are any free frames in the main memory. Okay, first it will find a free frame. So this frame is free, it will find a free frame. How to find a free frame? There is a frame table. Okay, in the frame table there is an there is one more column, that will says that how many free frames are there, what are the free frames. By looking at that particular column, it will come to this particular frame and find it out that this particular frame is free. Okay, then a new page, the referenced page, okay, whatever the page that has been referenced, that will be found and loaded into this particular free frame, as page size equal to frame size, there is no size problem. And once the page was loaded into this particular uh, frame, you need to change frame table contents, as well as you need to change page table contents, that this particular page now has to be changed from invalid to valid, and you need to add the page number to frame table, page number and information to page table. Once you change these particular details, then you need to restart the instruction. Now you need to restart the instruction. Now that particular instruction, whatever the address that wanted to whatever the page that has been referenced, now present in the main memory, and it will generate physical address, and the page will be accessed, the address will be accessed. Okay, this is one way. What is case one? Here system will find a free frame in the physical memory. If the system finds a free frame in the physical memory, this will be our work. If the main memory is full and the system is unable to find the free frame, okay, then what will be happen? Now we need to find a victim page. Okay, that means for a process, okay, for a process, it is referenced a page and the page is invalid. That means the page is not present in the main memory. Where the page is present? In the backing store. Okay, but the problem here is, previously we find a free frame, but the entire main memory is full. There is no free frames. There are no free frames. If you can unable to find the free frame, then we need to swap the existing page to hard disk, and a new page will be loaded into main memory. Okay, new page will be loaded into main memory. That means we need to swap the existing, that is one main memory page, that is one page of the particular process to hard disk. Okay, from main memory to hard disk, and we need to load the new page from hard disk to main memory, hard disk to main memory. Okay, that the page that we are selecting to transfer from main memory to hard disk, we will call it as victim page. We will call it as victim page. The transfer of a page from main memory to hard disk, we will call it as page out or swap out. Page out or swap out. Okay, the transfer of page from new page from hard disk to main memory in place of this particular old page, we will call it as page in or swap in. Page in or swap in. Okay, right? So first we need to find one particular victim page. Okay, and we need to send that particular victim page, transfer that particular victim page from main memory to hard disk, so that this particular page will be free. Then the new page that is referenced, okay, the reference page will be transferred from hard disk to main memory, hard disk to main memory. This will change again page table values as well as frame table values, but we need to be careful. If the page that we selected, this particular victim page that we selected during this particular main memory, if any contents are changed or not. Okay, we need to find out if there are any contents that are changed or not. Okay, so if any how to find out whether the contents are changed or not, we need to add one more bit called dirty bit to page table. We need to add one more bit called dirty bit to page table. Okay, so this particular page table will also have one more column, okay, that says that whether the page contents are modified or not, this particular victim page contents modified or not. Okay, so if the dirty bit is set, that particular bit, okay, the information will be known by using a bit called dirty bit. Bit called dirty bit. If dirty bit is set, that means that the contents of this particular victim page is modified. The contents of this particular page has been modified. Okay, if the contents of this particular page has been modified, before swap out, before transferring that particular page from main memory to hard disk, we need to save its contents, change its contents, okay, to disk. We need to save its contents from to disk. Okay, if the dirty bit is not set, dirty bit is not set, what is meant by that? There is no modifications in this particular page while it is present in the main memory, we can simply swap out from main memory to disk. Okay, so what is the importance of an dirty bit? The dirty bit says that whether the contents of the page is modified or not. If the contents of the page is modified, that particular page we will consider it as dirty page. Okay, all the dirty pages, before swapping out, we need to store that modifications or changes into disk. Then we swap out, then a new process will be swapping. Okay, so this is case two. First one, when the main memory has a free frame. Second one, when the main memory does not have a free frame, this particular swap in swap out will be done. Okay, but how do we select this particular victim page? That will be using page replacement algorithms. Okay, using some page replacement algorithms, we can find the victim page, and most of the times we'll find the victim page which are not been executed from the longest period of time. Okay.